All right, so example 26 says, using the substitution y is equal to vx, solve the differential equation x plus y dy by dx is equal to x minus y. So the substitution we're using is y is equal to vx. So let's differentiate. Dy by dx would be equal to, this is product, leave the first v, differentiate the second, differentiate x with respect to x is 1, plus leave the, differentiate the first, leave the second, so dv by dx x. All right, so substituting y and dy by dx, we get x minus y, which is, sorry, plus y, which is vx, into dy by dx, which is what? V plus dv by, plus what? X dv by dx is equal to x minus y, which is vx. Let us expand. If we expand, we get x vx, sorry, xv plus x squared dv by dx plus v squared x plus v x squared dv by dx. All right. Let's group like terms. So let's start by grouping like terms. Or let us put together the dv by dx's. So we have x squared dv by dx plus v x squared dv by dx. Should we carry this over? Yeah, let's carry it over. This is equal to x minus vx minus xv minus v squared x. All right, this looks like it goes. Over to the left, we have x squared dv by dx. In bracket, we have 1 plus v. And this is over to the right now. X is common, so we have x. Then we have 1 minus v squared. First of all, I made an error. Let's correct it. All right, so this should have been x minus vx minus vx again, because xv is vx. Then what else is over there? Minus xv squared. So what we have is x minus 2 Vx or xv, doesn't matter, plus, sorry, not plus, minus xv squared. So now we have x squared dv by dx, 1 plus v over x is common. We have 1 minus 2v minus v squared. This x cancels one of these x's. Let us do our variable separation. We have 1 plus v over 1 minus 2v minus v squared dv is equal to 1 over x dx. So that's variable separation. So if we integrate both sides, essentially we'll be able to solve the differential equation. All right, if we differentiate the denominator over here, the denominator is 1 minus 2v minus v squared. If we differentiate this with respect to v, we're going to get minus 2v, sorry, minus 2 minus 2v, which is minus 2, 1 plus v. So if we multiply the numerator over to the left, or if we multiply the numerator and the denominator by, if we multiply the numerator and the denominator by minus 2, we're going to get 1 minus 1 over 2 minus 2 into 1 plus v, all over 1 minus 2v minus v squared dv is equal to ln x plus c. So since the numerator is the differential of the denominator, we're going to get minus a half ln 1 minus 2v minus v squared, and this is equal to ln x plus c. All right, we need to get back y in there. Y is equal to vx, so v is equal to y over x. So if we go minus 1 over 2, remember y is equal to vx, so v would be equal to y over x. So we have ln 1 minus 2y over x minus y squared over x squared, and this is equal to ln x plus c. If I multiply both sides by minus 1, I'm going to get ln 1 minus 2y over x minus y squared over x squared is equal to minus 2 ln x minus 2c. And if I want, I could say ln 1 minus 2y over x minus y squared over x squared is equal to ln 1 over x squared minus 2c as my solution of the differential equation. Right. Example 27 says that if y depends on x and x is equal to e to the u, that if y depends on x and x is equal to e to the u, then x squared d2y by dx squared is equal to d2y by du squared minus y over du. Given that y satisfies the differential equation, So let's do the first part of the question. If y depends on x and x is equal to e to the u, we're to show that then x squared d2y by dx squared is equal to d2y by du squared minus y dy by du. Let's differentiate. Dx by du would be equal to e to the u, and dy by dx would be equal to dy by du times du by dx. Now, du by dx is 1 over dx by du. So this is dy by du times 1 over e to the u, or I could simply say it is e to the minus u dy by du. Now, d2y by dx squared would be equal to the differential of, with respect to u, of dy by dx multiplied by du by dx. So let's differentiate dy by dx with respect to u. If you do that, it's a product derivative. Here it is, and it's a product. So, and we're differentiating dy by dx with respect to u. It's a product, so it's leave the first. Differentiate the second. Plus differentiate the first, which is minus e to the minus u, leave the second, which is dy by du. All right, and we're to multiply this by du by dx, which is 1 over e to the u. All right, so this looks as if it is 1 over e to the 2u, open bracket, d2y by du squared minus dy by du. And so x squared d2y by dx squared would be equal to x squared. But remember, x is e to the u. So if x is e to the u, it means that x squared would be e to the 2u multiplied by 1 over e to the 2u, open bracket, d2y by du squared minus dy by du. These two cancel, and so we get x squared d2y, d2y by dx squared is equal to d2y by du squared minus dy by du. So that was the first part of the question. Next, what are we told? We're told that given that y satisfies the differential equation x squared d2y by dx squared minus, so it's x squared, we're to show x squared d2y by dx squared minus 2x dy by dx minus 10y is equal to 3x cubed. Show that d2y by du cube, du square minus 3 dy by du minus 10y is equal to 3e to the 3u, and solve the differential equation given y as a function of x. All right, so we're asked now, given that y satisfies this differential equation, x squared d2y by dx squared minus 2x dy by dx minus 10y is equal to 3x cubed. We're to show that d2y by du squared minus 3 dy by du minus 10y is equal to 3e to the 3u. So let's do our substitutions. We already showed that x squared d2y by dx squared is equal to d2y by du squared minus dy by du minus 2x, but remember x is what? E to the u, dy by dx, and dy by dx was 1 over e to the u dy by du. So this is 1 over e to the u dy by du. So it's minus 2x dy by dx minus 10y, but y, yes, y stays, is equal to 3x, which is what? E to the u cube. Simplifying, e to the u here cancels e to the u. We get d2y by du squared minus 3 dy by du minus 10y is equal to 3e to the 3u. So that is what we're asked to show. Then we're asked to solve this differential equation. All right, so now what we have is a second order differential, a non-homogeneous second order differential equation. All right, and to solve that, we have to first find the CF, which would be the solution of d2y by du squared minus 3 dy by du minus 10y is equal to 0. Now, to solve this, we need the auxiliary quadratic equation, which would be m squared minus 3m minus 10 is equal to 0. I think this can be factorized to m 5 minus plus 2 is equal to 0. So m plus 2 is equal to 0. M minus 5 is equal to 0. And so m is equal to minus 2, or m is equal to 5. And so the solution of the auxiliary quadratic equation would be y is equal to a e to the minus 2u plus b e to the 5u. We need also the particular integral, pi. Y is of the same form as f of x, or in this case, f of u, which is a e to the 3u. Dy by du is equal to 3a e to the 3u. And d2y by dx squared is equal to 9a e to the 3u. Now, substituting these into d2y by du squared minus 3dy by du minus 10y is equal to 3 e to the 3u. All right, so we're substituting it into d2y by du squared minus 3 dy by du minus 10y is equal to 3 e to the 3u. We're substituting into this, and when we do that, we're going to end up with 9 ae to the 3u minus 3 times 3 ae to the 3u minus 10y, which is ae to the 3u, is equal to 3e to the 3u. Once we do that, we're going to end up with minus 10 ae to the 3u is equal to 3e to the 3u. Therefore, a would be equal to minus 3/10. And the general solution of the differential equation would be y is equal to a e to the minus 2u plus b e to the 5u minus 3/10 e to the 3u. Now, we were asked to solve the differential equation so that we get y as a function of x and not y as a function of u. Remember, we were told initially that x is equal to e to the u. So let's separate some e to the u. We have a e to the u to the minus 2 power plus b e to the u to the 5th power minus 3/10 e to the u to the 3rd power. So now e to the u is equal to x. So this is a x to the minus 2, which is the same as saying over x squared, plus b x to the 5th power minus 3/10 x to the 3rd power. So y is equal to a over x squared plus b x to the 5th minus 3/10 x to the 3rd is the solution of the differential equation.